In our class today, we're going to discover insights about the consumer, you and me, how our preferences relate with reference to consumer or utility functions. We're going to look at in different scales, the properties that different scales have. Later on, we'll look at the concept of marginal rate of substitution. We'll come up with a budget constraint and what we call constrained optimization. Constrained optimization. To begin with, a consumer or a human being has a rational behavior, always wanting more for less. So our satisfaction is measured in units called utils. These utils are illustrated by an indifference curve which is downsloping and has about 4 properties. So we're going to look at in this unit behavior of individuals as consumers and the impact on alternative incentives of their decisions. We'll look at consumer behavior and how the consumers decide on the basket of goods and services they consume subject to constraint, which is their budget. We are also going to look at the consumer in terms of utility maximization by purchasing goods and services that will maximize their utility. And finally, look at utility as being the power that the consumer has to satisfy their need. So we're going to use a cardinal and ordinal utility approach, or the theories to calculate that. So to start with, we have what we call the cardinal utility theory. According to this theory, utility or satisfaction is measurable. It is assumed that the price that one person pays should be equal to the satisfaction that he or she must get from consuming a particular quantity of goods that they buy. And so the total utility is derived from 1 unit of a product or a service consumed is actually the total incremental satisfaction derived from or obtained from each unit consumed. So this is what our cardinal theory stipulates. And when we go to our ordinal theory, according to this theory, it disputes that utility can be measured. This theory actually uses indifference curves and utility functions to explain consumer behavior. So we're going to look at what an indifference curve is. This is a curve which shows various combinations of two goods that will give you satisfaction, optimal level of satisfaction. So these utility functions will be illustrated by curves that are downsloping and a concave. Look like this. These are called indifference curves. Indifference curves are parallel to each other. Indifference curve 1, indifference curve 2, indifference curve 3. So indifference curve 3 is higher than indifference curve 2, which is higher than indifference curve 1. So the human being has a rational behavior. As much as possible, you want to go up as much as possible. However, this individual is going to be constrained by a budget. So at A, you're under utilizing your resources. At B, you're optimal. At C, attainable, it's above the budget. So if you're dealing with goods Y and good X, these lines that we have here are the lines that will show you your utility in terms of the indifference curves. So these indifference curves are concave they are parallel, they are optimal at point B. And B is a point where the budget line is tangent to the indifference curve. This is where this budget line kisses our indifference curve. It is called the optimal bundle, where our marginal utility of x divided by the price of x will give you our marginal utility of y divided by the price of y. This is the point where we optimize our satisfaction. So it is subject to two equations. So we use what we call the Lagrangian function, where we have our utility function in terms of x and y plus our lambda subject to budget, income minus price of x times x minus price of y times y. Our budget line is given by our income equal to the price of x times x plus the price of y times y. This is how our budget constraint is derived. So if you're given an income of 100 kwacha, which you want to spend between two goods and good X, costs 4 kwacha, and good Y costs 5 kwacha. How do we come up with budget line? Our budget line is given by M is equal to X times X, Y times Y. What becomes our income equation? 100 is equal to what? 4x plus 5y. So this is what we call our budget line. It is given by this. So this budget line looks like the demand equation. We have our y and our x there. All the letters are on one side. 4 into 100 is 20. So to cut the y at 5 into 100 is what? 4 into 100, what do we get? 25, not 20. 5 into 100 is 1 which gives us 20. So to know where it's cutting, x here, we'll divide 4 into 100, we get 25. To get the y-intercept, we're going to divide 5 into 100, we get 20. This is how we draw our budget line. So this is how the budget line will look like. Now, this budget line can have 4 kinds of movement. Number 1, you can have movement along here. It's a code movements along due to factors of demand to do with price. Other than price, it will cause a shift in demand. Now the price will cause movement as follows. There will be a tilt outward or a tilt inward. If the price of one good goes up or down. There also could be a shift inwards and a shift outward. If the income, the other factors will change. So this is what consumer behavior is really all about. So you are told that your income is 1,000 and the price of good X is 20 kwacha. And the price of good Y is 10 kwacha. Let me come up with a budget line. How do we compute the budget line? Anyone? M is equal to X and what? X, Y, and what? Y. This is our M.
1,000.
1,000. This is our X.
20.
20. What is our Y? So how do we plot this? Do we plot this budget line? We simply divide the intercepts here. For X, 20 into 1,000, where will the X cut? 20 into 1,000, what do we get? 20 into 1,000, what do we get?
50.
50. For Y, 10 into 1,000, what do we get?
100.
100. So how do we plot this?
$50 on the x-axis and y on the, 100 on the y-axis.
Okay. 100 on the Y, X 50. 100. What is on the X? 50. And on the Y we have what? That's how you plot this budget line. Yeah. Okay. So suppose the price of Y increased from 10 kwacha to 15 kwacha. What becomes our new budget line? So 1,000 is equal to X still remains the same, 20. X, the Y becomes what? 15Y. So where does it cut x-axis? 20 into 1,000, we get 50. Where does it cut the y-axis? 1,000 divided by 15. What do we get? 1,000 divided by 15 gives us 6.66. So how do we plot this? On the x, it will still maintain the 50. On the y, is putting inward or outward? It's putting inward here. So here we're going to consume 66 units of Y. Why? Because good Y has become expensive. So you buy less of that. Are we following? So a change in price of one commodity. So if good Y had become cheap, it would have tilted outward. So that you buy more of what? Good Y, whilst maintaining good X. Similarly, where we have 100 and 10, 150. If it was actually good X, which became cheap. The tilt would have been outward on the good X. So the good that is becoming cheap, you're buying more of it. You're tilted outward. The good X was becoming expensive, you're tilted inward. So this is how we go about it. All right. So we now proceed, unless there are any questions. All right. So let's move now to the other part of the calculation, where you're given a utility function. The utility function is given with respect to values of x and y. So if you're going to differentiate u over the x, we're going to call this the marginal utility of x. We're going to differentiate u over the y, we're going to call this the marginal utility of y. We use what we call implicit differentiation when you're dealing with calculus. You remember from our calculus class, where we have y is equal to x 5x4. Who can differentiate this? U over the y becomes what? U over the x becomes what? A marginal utility of x. So when differentiate using the power rule, we're going to get 20x what? 20x3. How do we get this? Multiply 5 times 4 is 20. Subtract 1 from the 4, we get a 3. So this is our marginal utility of x. If our u was 10 y3, so this will be our du over dy. When differentiate this, it will be called a marginal utility of y. What becomes our computation?
30x squared.
30y. All right. So if we had a combination of both of them, we had 4x, 5, y, 3. So we will start with marginal utility of x. The shortcut is ux. So we're differentiating with respect to x. So we leave y as it is, y3. We're going to differentiate 4x, 5. What is the derivative of 4x to the power 5? 20x4. And again, we differentiate the u over dy, where we get our derivative of y. So interested in the y, meaning just this part of the x will be the dummy. Dummy means leave it as it is. So leave x5 as it is. We're going to remain with what? 4y3. 4y3 becomes what? 12y2. That is how we differentiate it. All right. So if you have a derivative like this one, x y to the power half, we first differentiate, we expand this, it will be u is equal to 2x to the power half and y to the power half. The u over the x is a marginal utility of what? X. So our dummy in this case will be what? y half. So we're going to differentiate 2x half. So 2x half times 2 is 1. We never write 1. Half minus 1, it is half to the power negative 1. So if you want to leave this the positive index, then the guy who's negative will go down. So we're going to have x half down in the positive index. If you want to find du over dy, this is the marginal utility of y. Our dummy in this case will be x. We're interested in the y, so cut this and bring it as it is. So we're going to remain with 2y half. When differentiate 2y half, what we get? Half times 2 is 1, invisible 1. All right, then differentiate the y, subtract 1, you have negative half. So this will give us x half, y half. I think those of you who attended my calculus class, I never have to explain this. So help me, if I have this utility function, 100 x3 and y2. Who wants to differentiate u dx? U dx. What do we get? U dx, the marginal utility of x. What is our dummy in this case? Our dummy is y2. So we're going to differentiate 100 x3 to become what? 300 x what? x2. How about MUY? Is the U dy. Our dummy x3. Our derivative, want to differentiate 100 y2. 100 y2 becomes what? 200 y. So this is how we differentiate. Let's get back to the note. So the assumptions of indifference curves: number 1, all the money is spent on consumption. Number 2, this consumer has only 2 products to spend on. Number 3, every consumer has a desired level of consumption. Number 4, the consumer has a combination of the 2. So we're given the following schedules of mangoes and bananas. We're asked to come up with an indifference curve. So the indifference curve will look something like this, downsloping. So meaning each of these points A, B, C, D, E, F are all along this indifference curve. Satisfaction is the same. Remember what I said about indifference curves? Indifference curves show points that join with the same satisfaction. So for instance, the satisfaction here is what? 7, here it is 8, here it is 9. So regardless of where it is, whether it is here, whether it's here, whether it's here, the satisfaction will be what? 7. This is another line joining points of both y and x that offers the same what? Satisfaction along this whole line. So this line is called an indifference curve. So these are the points that are optimal. We have bananas and we have oranges. So suppose Panda has a 500 kwacha to spend on oranges and bananas. The price of a banana is, let's say, 10 kwacha. Price of an apple is 50 kwacha. Write down Chanda's budget line. So the budget line will be 500 is equal to what? 10 banana plus 50 apple. You can use X and Y. So you can use your X or Y plane there. You can call these apples if you want. These are bananas. And we had 0 there. So where would we cut the axis on the B? Divide by 10. The axis will be at what? At 50. All right. So when you divide 10 into 500, you get the 50 there. That is on the banana. On the apple, we divide by 50 on both sides. We're going to get a what? A 10. So this is our budget line. You can even use your key if you want to let A be Y and X be the apples, or you leave it as it is. 50, 500 is equal to 10B plus 50A. Then a question will come. Suppose Chanda consumes 5 apples. How many oranges will he consume? So we go to the apples, where there's apples, we put what? 5. So we're going to have 500 equal to 10B plus 50A. So where there's A, we put 5. So we want to calculate how many would be for the bananas. So when we compute this, we have 250, which will go on the other side. So we're going to have 500 minus what? 250 is equal to 10B. So this side we're going to have 250 is equal to 10B. To calculate the number of bananas that Chanda will consume, we divide both sides by 10. So meaning our B is equal to what? 25. So when there are 10, when there are 5 apples, how many bananas can Chanda consume? 25 bananas. So this is still along this what? This is still along this straight line. It's still optimal, the same satisfaction that we are having. So using this very equation, I can ask a question. Suppose instead Chanda consumes 10 bananas. How many apples can he consume? Besides to consume 10 bananas, how many apples they consume? What we do, where there are bananas, we put 10. So here we put 10 there. So we're going to have 500, this is 100, this is 50A. So this 100, when it goes to the other side, it will subtract. So we're going to have 400 is equal to what? 50A. So to calculate how many apples we're going to have, we divide both sides by 50. So our apples will therefore give us 8. So this one will give us another combination. So when there are 8, when there are how many? When there are 10 bananas, apples will be 8. So this is the movement that happens along that curve. So This is in different scales. So in different scales have these properties in different scale 1, different scale 2, in different scale 3. So the properties are in different scale always has a negative slope. In different scales don't touch each other. They don't intersect each other. They are convex about the origin. And along the indifference scale, the total utility is constant, but the marginal rate of substitution changes from one point to another. The marginal rate of substitution usually changes from one point to another, and satisfaction is maximized at the point of tangency. The marginal rate of substitution simply is described or defined as a quantity of one product which a consumer is willing to sacrifice for the other by buying an extra unit of another product, but remaining within the same indifference scale. So you saw how I was able to navigate, say, at 25 bananas, we can consume 5 apples. Suppose we're willing to sacrifice some, how many bananas? 15 bananas downward. So the 15 that we are foregoing is helping us assume 3 more apples. So this is called opportunity cost. It's a trade-off. We're trading off 15 bananas for 3 extra apples. So the marginal rate of substitution measures how many units of one product you can forego for the other. So marginal rate of substitution X for Y is given by negative price of X over price of Y. If the MRS was starting with Y for X, we're going to have negative price of Y over price of X. Is negative because we're exchanging one for the other. It's an inverse relationship. In economics, it's about principles. You need to hear me very carefully. Once you miss one point, you are gone. So the marginal rate of substitution X for Y, you divide the price of X over the price of Y. All right. So any questions so far? Mr. Banda has 100 kwacha to spend on 2 goods. Good X is 10 kwacha. Good Y is 40 kwacha. Can somebody come up with a budget line? What is our budget line? Later on, we're told that if his budget increases from 100 kwacha to 101, his utility will increase from 4 utils to 4.05. So we are going to calculate the number of things. Number one, the budget line. So budget line is going to be given by what? 100 is equal to NX plus 40Y. But B, we're asked to find the marginal rate of substitution X for Y. So here we know marginal rate of substitution is price of X over price of Y. So here we're going to have negative 10 over 40, which is negative 0.25. they asked you to find the marginal rate of substitution y for x. Negative py over dx, which is negative 40 over 10 to give you negative 4. Then what is the impact of a 1/4 increase in your budget? The impact of a 1/4 increase in the budget is your lambda. Lambda is the difference between the utils, the second util minus the first util. So we had second util after we increase the budget 1/4 from 100 to 101. Our increase in utility was from 4 to 4.05, which gives us 0.05 utils. So it means any increase by 1/4 in your budget will increase your satisfaction by 0.05 utils. This is what we use to define when you're dealing with lambda. Part B, find a marginal utility of x when optimum. Optimum, the marginal utility. I told you that marginal utility of u of x over the price of is the same as a lambda. Or marginal utility of y divided by the price of y. This is the Lagrangian multiplier. So when you cross multiply, marginal utility optimum at x is a lambda times the price of x. So we just calculated lambda here 0.05, and the price of x is 10/4. So here at optimum, we're going to get 0.5 utils. For this one here, marginal utility of y is equal to lambda times the price of y. So our lambda is 0.05. So calculated, the price of y is 40. So when you compute there, you get 2 utils. These ones are optimum. Sometimes you're given a utility function. As follows. The utility function is given by half of xy. The price of x we're told is 1/4. The price of y is 40/4. And your income is denoted by I or by M, with the 80/4. We are asked, how do you find the budget line? Budget line, who remembers? How do you find the budget line? I is equal to price of x and x plus price of y times y. So here 80 is equal to 10x plus 40y. That's our budget line. Part B, you can use the Lagrangian multiplier or the optimum bundle to maximize utility. So you'll be asked maximize what? Utility. Now this is where 15 marks come from. Remember, when I was trying to show you the indifference scale. Optimum bundle happened at a point where our utility function and our budget line meet. This will give us how many units of y and how many units of x will maximize our satisfaction. And this optimum bundle is given by the marginal utility of x over the price of x should be equal to the marginal utility of y over the price of y. So how do we find the marginal utility of x and y? So when we expand this, we already established that we just distribute the power to both of them. Now how do you find the marginal utility of x? Our dummy here is what? Y half. Then you differentiate half times 2 is 1. Half minus 1 is what? Negative half. The marginal utility of what? Y. Our dummy here is x half. X half. Then what do we remain with? Y to the power half. When you multiply half times 1, half times 2 is 1. Then subtract half minus 1. What do we get? Y negative half. So these are the partial derivatives that we're going to use to optimize our bundle. Remember, we optimize the bundle when mu x over price of x is equal to mu y over price of y. So here mu x is x negative half, y positive half. Mu y, the negative is on the y. The price of x was what? 10 kwacha. The price of y was what? 40 kwacha. So the guy with the negative goes down. So which one of the two will go down? X. So here we're going to have 10 x half. And here we're going to have 40 y half. When you cross multiply, there's a 1 there here. 1 times 10 is 10. X half times x half is x. So we're just going to have 10x. Y half and 40 y half, we're going to get 40 y. We know how the rules of indices really behave. The powers will add. Half plus half is 1. When divided by 10 on both sides, x is equal to what? 4y. So this is the one that you're going to use back into the budget line. X is equal to 4y. Remember our budget was what? 80 is equal to 10x plus 40y. So we've just established that our x is equal to what? 4y. So where there's x, we're going to say 80 is equal to 10. But where there's x, we're going to put 4y. So what are we going to have? We're going to have 80 is equal to 40y plus 40y, which is 8y. So when you're going to divide both sides by 80, our y is going to be 1. This one, you can put it back in the y here, so that our x is equal to 4. 4 times 1, you get 4. So how many units to maximize our production or satisfaction? Y, we're going to get 1 unit. X, we're going to get 4 units. So this is how we use two functions optimally. This is a headache that you need really think. Okay. This is where I hate this course for you because you need to think now. So utility functions we are given in here. So the budget line I've already explained simply shows you the possible combinations of the products that a consumer can afford to pay for. This is a budget line. We have good A and good B. Budget line looks like a demand curve. So when you're sketching a budget line, suppose the consumer income is 40, good Y and X are 1 quarter and 2 quarter respectively. Our budget line therefore is going to be 40. Is got what? 1x, although we never write 1 just for illustration purposes, plus 2y. So to illustrate this, we divide on the y and the x there. So 1 into 40 is 40. So this will be at 40. And the x, 2 into 40, we're going to get 20. And this is at 0. So this is the simplest way you can illustrate linear equations. So to cut 40 here and 20 there. All right. So this is the whole explanation here, which I've simplified in 1 second. So here to cut at 40 for the y, and here to cut the 20 for the x. So this is how we get the budget line. So the slope of the budget line is the same as the marginal rate of substitution x for y. It is given by the price of x over the price of y. So Mr. Banda, we said, had 100 kwacha as his budget. 10 kwacha was for good x, and 40 kwacha was for good y. So the slope for Mr. Banda will be price of x over price of y, but negative. It's a demand function. So it will be 10 over 40, which we got as negative 0.25. So the slope of a budget line is simply price of x over the price of y. So in this case, the price of x was what? The price of x was 2 kwacha. The price of y was 1 kwacha. So also different scales, we say whenever they are tangent to the budget line, we are actually at equilibrium, optimizing our production or satisfaction. This is according to the what? Ordinal utility theory. So if we're going to elongate this theory, it makes what we have, which is called the Lagrangian function, which has a utility function given in terms of x and y, plus our Lagrangian modifier, which gives us the impact of an increment in our budget line, even by 1 kwacha or $1. So this is what we call Lagrange. This whole equation is simplified by a point at equilibrium, which is optimal, simply by marginal utility of x divided by the price of x should be equal to the marginal utility of y over the price of y. So marginal rate of substitution, like I said, x for y is the same as the slope. So you need to be careful, x for y. So this is how the illustrations are done. And there's a truth, and a price of good x becomes cheaper. So a price for it was actually swapped. If the price of good x falls, you're going to, no, it's actually correct. If the price falls, you're going to demand more of this good x. If the price increases, you're going to demand less. So let's for a rise, more for a fall. Similarly here, the price for good Y, if it falls, you demand more of it. If it rises, demand less of it. So these are the movement of clockwise and anti-clockwise, which I've already explained. So our budget line is given by price of good X times X, price of good Y times Y. This will give us our income, which is denoted by Y or I or Y. All these stand for income. You can use any of these letters. All right, so using constraint optimization, we're given a utility function. U is equal to what? N X squared and Y. How do we find the optimum bundle? And how can we show this graphically? All right. So somebody help as we conclude our class. Now, as we conclude our class, what is the budget line of this very equation of Jacob? I hope I will talk to myself. These people sound to be very tired. I don't know why. So we're given our utility function. U is equal to 10 x2 and Y. Price of X is given by 10 kwacha. Price of Y we're given as 5 kwacha, and the income at Y is given by 150. The budget line therefore will be Y is equal to what? Px x py y. So what becomes the budget line? 150 is equal to 10x plus 5y. So this is our budget line. How do we draw this? The x will cut where? At 15 by dividing by 10 here. And the y will cut where? At 30 by dividing by 5 here. So how do we draw the budget line? X cuts at 15, y cuts at what? At 30, x 15, y at 30. So this is how you sketch this graph. Show the graph. What is the equation of this budget line? What is the optimal consumption? So we need to differentiate this guy here. So what is our mu x? Mu x there. Mu is y. We're going to differentiate 10x to 2 to get x. And what is our MUY? Our dummy there will be what? X squared. So we're going to remain with 10y. Setting 10y, this gives us what? 10. So now we go to the optimal bundle. How do we optimize? MUX over price of x. That's equal to MUY over price of y. What is our MUX? MUX is 20 xy over the price of x, which is 10. Then we go here, our MUY mu y is 10x squared over the price of y is 5. So cross multiply 100 times 10x squared, we're going to get 100x squared. And here we're going to have what? 100xy. Okay, so we need to make one thing subject. So we can divide firstly by 100 on both sides. So we're going to have what? X squared is equal to xy. After dividing by 100, then we make what? Y subject. So we can divide by x on both sides. So here we're going to have x is equal to y. Then we substitute in the budget line. X is equal to y. What is our budget line? 150 is equal to 10x plus 5y. 150 is equal to 10x plus 5y. Is this so? 150 is equal to 10x plus 5y. Since x is equal to y, you can substitute any of these ones. X is y, so you just substitute on one. Where there's x, we put y. So here we're going to have 10y plus 5y, which will give us 150 is equal to 15y. And we divide both sides by 15, meaning our y therefore will be equal to what? Y therefore will be equal to what? 10. So since x is y, the value for x and the value for y are the same. So our utility function, we already had it, was what? Our utility function was 10x squared and y. 10x squared and y. So this one cuts here at 10, cuts here at also 10. So this is good y, and this is good x. So how many you need to maximize satisfaction? 10 of each. So we end here. Let's any questions? I'm sure some of you are very lost.
I'm very lost.
Till you get to have time, we're going to discuss this thrice. Yeah. Especially those of you who could have missed my other class.
Me too, I'm lost.
You have to be lost of a class. It must humble you enough to go and read much. Okay. So unless any other content, I will send the video in the paid up class. So